Hi, I'm Clement, and this is the second part of my presentation on containerization, and the first part is linked in the description below. Hello, so in this part of the tutorial, you're going to be installing Docker quickly, and it's a simple process. You just need to go to hub.docker.com and get the image for your operating system and then download it. They require you to create an account before you could download anything with Docker. So you need to get an account, create an account, and verify it. After you verify your account, it brings you back to the Docker Hub page where you're able to start your download and download it. The installation is very simple and you should get up and running in no time. Once the installation has completed, you just need to start Docker and you'll see Docker starting on your respective operating system. I'm on the Mac now, so you would see the little Docker icon at the top notification bar, and it says that Docker is starting. It takes a few minutes, and then Docker gets set up and it's running. Now we are going to use Docker, but for the purpose of this tutorial, a YouTube Flask repository was created, and you just have to clone it. The link to that repo is in the description below, and once the repo is cloned, you can open it in your favorite text editor and start working along with the tutorial. So the first thing we're going to do is to look through the folder and to see the respective files in it. We can see that it's just a simple Flask app which is in it, and then we have a Docker file and a Docker compose file as part of this. So the first thing you need to do is to get the appropriate Docker compose file configuration, and we are running on Python 3. We're going to use the Python app.py command to start our application. Docker compose is a special kind of file. It helps us to aggregate lots of containers together and run them at once at a go. So in this file, I'm just running my application, but if you had a database, you could just have added this as a separate container and run it. So you're going into a terminal, and we're simply going to change the directory to our deployments directory or folder, and we're going to run docker compose app. Docker compose app is a special command, and it helps us to build our image from our docker compose file, which would incorporate all other Docker files. So if you're able to go to the address of or the IP address of the Flask app, which is running now in the Docker container, realize that we're able to get to the application, and the application is up and running inside the container. It simply means that the container has its separate namespaces and process IDs. So now if you want to change anything in our application, we should be able to change it, but realize that any change there doesn't reflect in the container that we are running. So this is where we need volumes. Volumes just help us to keep our data persistent in our containers. So the volume is going to link up our file, which is the app.py, to our container and make sure that any changes that are made there reflect in it. So just by adding a volume, any change in our file should reflect in our application, and we are able to develop faster. The next thing we're going to deal with is Kubernetes. To get Kubernetes up and running, you need a virtual machine. So we're going to head over to our browser and get our virtual machine. I chose VirtualBox for this tutorial. We'll quickly install it, and once we are done, we'll have to install Kubernetes. So I went to the Kubernetes site and found the command to install Kubernetes. You could find it on the Kubernetes official website. So after installing Kubernetes, you'd have to start Kubernetes. Minikube is the version of Kubernetes that runs locally, not on servers, on local machines. So we'll quickly install that and start the Kubernetes server or VM on our machine. So Kubernetes status shows us the status of our VM or Kubernetes server now, and we can see that Kubernetes VM is up and running. We have a master node, which is the Minikube, and for our ports, we don't have any ports existing yet. The add-on list shows us the configurations that can be set. To be able to show the power of Kubernetes, we are going to enable Heapstar and Matrix Server. So we'll start up by creating a pod. or running the deployment, which is literally a container. So when you talk of pods in Kubernetes, they are literally containers that are running. So Kubernetes get deployment shows us that we have one deployment here, which is kubetest, which is our test deployment, which is made from a sample image from the Google container repository. So we could go in and see that when we describe our deployment, we realize that it pulled the image and created a pod from the image. So with the pod, we realize that we have the number of running instances as just one. So here we are going to do a few things with Kubernetes, and this is where the Kubernetes really shines. So you're able to scale up applications from just one instance to 4 instances, and just like that, we realize that 4 pods have been formed from or for our different instances. So if demand on a server should increase, we could do this to scale up. We could also scale down, so from 4 to 2. So that if demand should decrease, we have just 2 running instances, so that we don't have to run all our resources down. And we can see that the pods actually reduce from 4 down to 2. So now we have just 2 running instances. So up to this point, our application is just running within our Kubernetes VM, but we want to expose it to the outside world. So we could apply a load balancer, which would allow load to be balanced between the 2 pods that we have running. So if we try accessing our pods or our application from the outside, we realize that every time that we access the application, we are able to just hit a different port. So it's not the same port every time. So you can see that different ports are hit on different requests, which means that our application is actually scaling and load balancing at the same time. So your ports can self-heal. So even if a port is deleted, it can regenerate itself based on the scale that is given to the application. So you could just stop your Kubernetes runtime just by applying the kube stop, mini kube stop. Okay, so we want to auto scale because we don't always want to be setting the scale ourselves. So we'd have to run Kubernetes, and we are running it with a different image this time, just to show what's possible. And it's a PHP Apache image. Auto scaling will set the maximum number of instances that we'll need and the percentage at which the CPU should be used, at which we should start scaling. So we realize that when we start our application, we started with just like 1 instance, and when we hit our server several times, we realize that the CPU usage goes high, and realize that then our application scales to 4 instances based on the CPU usage. So that way we are able to auto scale our application and able to get the best performance. So when we look at the number of pods, we realize that there are just 4 pods running right now. And so when we should stop bombarding our server, we realize that the number of instances scales back down to 1, which means that our server is now auto-scaling. So thank you for watching this tutorial, and I hope you enjoyed it. It's bye for now.